In this method, we connect between W2, U2 and V2 on only one side. This will give us our star or Y equivalent connection. Now, when we pass electricity through the phases, we see the electrons are shared between the terminals of the phases. Due to their design differences, the amount of current flowing in the star and delta configuration is very different. Let's have a look at the difference between the star and delta configurations. Let's say we have the motor connected in delta, with a supply voltage of 400 volts. That means when we use a multimeter to measure the voltage between any two phases, we will get a reading of 400 volts. We call this our line-to-line voltage. Now, if we measure across the two ends of a coil, we again see the line-to-line voltage of 400 volts. Let's say each coil has a resistance, or impedance as this is alternating current, of 20 ohms. That means we will get a current reading on the coil of 20 amps. We can calculate that from 400 volts divided by 20 ohms, which is 20 amps. But the current in the line will be different. It will be 34.6 amps. We get that from 20 amps multiplied by the square root of 3, which is 34.6 amps. That's because each phase is connected to two coils. Now, if we look at the star or Y configuration, we again have a line-to-line voltage of 400 volts. We see that if we measure between any two phases. But with the star configuration, all our coils are connected together and meet at the star point or neutral point. It's from this point that we can run a neutral wire if needed. So this time, when we measure the voltage across the ends of any coil, we get a lower voltage of 230 volts. That's because the phase isn't directly connected to two coils, like in the delta configuration. One end of the coil is connected to a phase, but the other is connected to a shared point. So the voltage is therefore shared. The voltage is less as one phase is always in reverse. We can calculate this by 400 volts divided by the square root of 3, which is 230 volts. As the voltage is less, the current will be 2. If this coil also has an impedance of 20 ohms, then 230 volts divided by 20 amps equals 11.5 amps. The line current will also therefore be the same at 11.5 amps. So we can see from the delta configuration, the coil is exposed to the full 400 volts between two phases, but the star configuration is only exposed to 230 volts between the phase and the neutral point. So the star uses less voltage and less current compared to the delta version. Okay, that's it for this video, but to continue learning about electrical engineering, check out one of the videos on screen now and I'll catch you there for the next lesson. Don't forget to follow us on Facebook, Instagram, LinkedIn, as well as theengineeringmindset.com.